Hello, this is the third module of the Odyssey Siemens project that I put together. We have already covered configuring hardware, downloading the PLC simulator. I'm going to review a few things in this module and also continue with building some functions and maybe some function blocks, data blocks, some of the different objects that we use in Siemens. As I mentioned previously, I'm not sure exactly where this project's going to go yet, but I plan to keep recording and keep adding modules to it and let it get bigger and bigger. Hope you enjoy it. This is about where we left off in the last video, and there's a few things that I wanted to touch on and go into a little more detail on from the last video. First, you can see here that we are online, and there's a couple signals that you are looking at the real logic inside of the processor. One of them is this light blue shading up here at the top of the window, and the other is this little run icon down here. Looks like a scrolling bar graph. So these glasses up here, these little spectacles, if I turn that off, you can see that this is no longer light blue, and it says offline here. I can just go up and click on those glasses and it reconnects and I can see it run again. So that's one of the signs. Another thing that I wanted to review, I talked a little bit about making sure that you don't put the processor up here in run. You need to put it in run P. So this is very much like the key switch in Allen Bradley and in the older Siemens processors. Stop, of course, is stop. You're not processing the logic. It says down here that you are stopped. If you put it into run, you are running, but that is very much like the run position on the key switch. You cannot download and you can't change anything. So it's not particularly useful, obviously, on a simulator to do that, since you can't change the program. You can't modify it. So you always want to be in run P rather than run. And what'll happen is sometimes you'll change the code, you'll try to download, and it will not allow you to do that because you're in the run mode. So things to keep in mind. Another thing that I kind of want to review here, this is the offline version of the program in the manager. There is another view of the program, and that's this one. So what I'm opening here is the online version of the program, and what you see here, you do not usually ever open anything from here. But what this shows is this shows everything that's actually in the processor. So you can see here a lot of SFBs, SFCs, plus our one lonely little OB1, which was the routine that we put in here before. So these cannot be deleted. All these SFBs and SFCs, they're in the processor all the time. They're things that the operating system needs to be able to run. So some of the things in here, like SFB 4 and 5, for instance, are timers. SFB 3, 4, and 5. They're timers that you can use. They're IEC timers, so they have data blocks associated with them. They're things you can call up. But what this is useful for, this view, is seeing what's actually in the processor. So if you look here and you've created a bunch of blocks, but you don't remember if you've downloaded them into the processor, this is an easy way, opening up the online view, to see what you've downloaded into the processor. So you can see here that OB1 is present. But for instance, if I create an FC, which I'm going to do soon here, or a DB, and I forget to download it, I can always go here into the online view to see whether I did put it into the processor. And we'll be talking a little more about the online and offline differences a little bit later. Usually when you're done with this, you just want to close it, because otherwise you'll accidentally try to open blocks with it and things like that. At this point, we're going to do a few basic things here. First thing I'm going to do, we're going to go back to OB1, take a look at this logic, and I don't really want this logic in here. The only thing that I want in this block is things that apply to the entire program or calls to subroutines, which are the FCs and FBs that we talked about. So I'm going to delete this rung, and then just because I delete it here does not mean that it's gone from inside of the processor. So you notice here the glasses are off. I cannot monitor what's in the processor because what I've just done made this block not match what's in the processor. If I save this, it is saved in this offline view, and at that point I can download it. It says it already exists. Do I want to overwrite it? Yes, I do. And now there's really nothing to monitor, right? So I also don't have my glasses here. The next thing we're going to do is create an FC so that we have something to call. As I mentioned before, an FC, or a function, is the same thing as a subroutine in Allen Bradley. There are a couple little minor differences, but there are two different types of subroutines with Siemens. There are FCs, functions, and FBs, which are function blocks. And as I mentioned in an earlier module, the FBs have data blocks associated with them. This is once again your chance to name this block. I'm going to name it System. So this is where we're going to put some of our system functions that apply to the entire simulated machine or system. I say OK, and again, this is an opportunity to take a look at the online view, and you see OB1 is in here, FC1 is not. So this is one of those cases I was talking about before. So I'm going to download FC1, and if for some reason I forgot whether I had downloaded it, this is an opportunity to check whether it is in the processor. Even though there's no code in it and it's not being called, at least it's in the processor right now. If I want to call this block, even though there's nothing in it, I can go down here into FC blocks, and there it is. Because I created it and I named it, there it is in the function FC blocks folder. To call it, I'm going to stick a new rung in here. This is the new rung icon, and I can simply drag FC1 over to it, and you can see the name that I gave it, System. That name also appears in something called the symbol table. Symbol table is very important, and we are going to create some symbols. I'm going to go ahead and create a couple right now. Let's take a look at what the symbol table looks like. So if I go up to the S7 program folder, you can see the blocks that I have, the sources. You can see the subfolders down here, but you can also see this symbols folder. So I double click that. I get the symbol table, and you can see a couple of symbols already in here. So main is OB1, that was the main routine, and the system routine I just created is in FC1. So the symbol table holds everything that you name. You can put new symbols in here easily. We're going to name a few things in the symbol table. I'm going to name, for instance, some I/O and some commonly used functions. First we'll do is, how about an always on bit? That's always a good thing to have. And always off, we'll make the always off bit first. Now another thing about symbols that's interesting in Siemens is, notice I put a space here. I can actually use a space and I don't have to use an underscore. The address for this would normally automatically increment to the FC, but I want to use M0.0. So M0.0 is a very common address for always off. You'll see that in a lot of programs. And you notice that it changes the data type automatically to bool. Now in this Odyssey project, I'm not going to explain how bits and bytes and bools and all those things work. You're going to have to get that from either another one of my videos or somebody else's. But the M registers, There's about 256 bytes minimum usually in a Siemens PLC, and they are all bytes, right? And you can use the individual bools out of the bytes, or you can make words out of them, or whatever. So we'll do a little bit of that here. We make an always on. Notice how it automatically increments to M0.1. That's kind of a nice feature. We'll create a couple other ones here. I'm going to say system fault. That's always a good thing to have. Now these M registers are kind of just throwaway things. You can declare words or double words or reals or whatever you want to in here. And just for playing around with, maybe I'll put a word in here. We'll say fault number. How about that? And in this case, this is not a bool. It doesn't know that that's not what I want to create. So I'm going to use a memory word. And the first available memory word would have been memory word 2. But I'm going to use memory word 10. Now, when you define a memory word, you will get either a word or an integer. And the problem with the word is that you cannot do math with it. So I'm going to change this immediately. I usually do that to an integer in case later I want to do some math. Now this fault number, memory word 10, actually takes up memory byte 10 and memory byte 11. So the next available word would be memory word 12. So we'll say message number. We'll do that too. That's just something sometimes we can use. And notice that it automatically increments to the next available word. It's Siemens protocol for programmers to usually only use even numbers anyway for words. Even if you do have an available, for instance here, MW1, we would not use that. You want to use even numbers. So 10, 12, 14, etc. And I changed it to an integer. We'll go ahead and name some of our I/O, and I think I'm going to pause this video at this point, and we'll pick up the I/O in a later lesson, but this will allow me to put a bunch of inputs and outputs in here. We'll go ahead and create a couple here online before I stop the video. We'll use I0.0 and we'll make that an e-stop. Whoops, put the address in the wrong place. We'll call this e-stop PB, and we'll give it an address of I0.0. Of course, it's a bool. I can also put a comment in here, and we'll make this the emergency stop push button. What I'll do is I'll create a bunch more symbols for the next video, and we'll kind of start there. Thanks a lot.